trapezium rule. So if we want to find an estimate for the area under the curve y between A and B, this is what we will use. H, that is the distance between each of the trapezia, each of the bars. Y0 is the height of the first edge of the trapezia. Yn is the last edge. And then we have two lots of y1, y2, y3, y4 up to y equals n minus 1 here, and that is our trapezium rule. So our first example here, example number 1, taken from C4 January 2010. The sketch shows the curve with equation y equals x ln x. X must be greater than or equal to 1. The finite region R is bounded by the curve, the x-axis, and the line x equals 4, as shown here. The table shows the corresponding values of x and y for it. So when x is 1, y is 0. When x is 1.5, that's 0.608. 2 and 2.5 aren't given. 3 is 3.296. 3.5 is 4.385. And when x is 4, y has a value of 5.545. So first part of this question is complete the table with the values of y corresponding to x equals 2, x equals 2.5. So that is easy enough. So x is 2, we've got 2 log 2, and it wants the answers to 3 decimal places. So that is going to be 1.386 in there, and then 2.5 log 2.5, and we have 2.291 to 3 decimal places. So easy start to the question. Part B, here we go, the reason why we're here. Use the trapezium rule with all the values of y in the table to obtain an estimate for the area of R, giving your answer to 2 decimal places. So we are going to use the trapezium rule with this information. So the first thing we need to talk about is how many trapezia are we going to use in the question. So 1, 1.5, 2, 2.5, 3, 3.54, 1, 2, 3, 4, 5, 6, 7. That means we will use 6 bars, because the first bar from 1 to 1.5, if I crudely draw that on here now, 1 to 1.5, I know it's a triangle, but we'll call that the first trapezium. From 1.5 to 2 will be the second, 2 to 2.5 will be the third, 2.5 to 3, 3 to 3.5, and 4. So 1, 2, 3, 4, 5, 6, 7 values of x, 7 values for y, 1, 2, 3, 4, 5, 6 areas that we will be calculating. So, not overly complicated, into our formula. From 1 to 4 for y dx, so y is x ln x. That can be approximated by a half. So h within our formula is the height of each of these here, and we can see that they are all going up for x here now by 0.5, add 0.5, add 0.5. So a half times a half. And then we want our y value. So the first y value is 0. The last y value is 5.545. So the first one plus the last one plus 2 lots of the ones in between. 0.608 plus, now I'm running out of room here now, so I'm just doing ... I would recommend writing them all down. There we go. So that is what we're going to type into our calculators, approximately equal to. So I'm just going to pause it here now while I do some calculator work. So I have typed all that into my calculator and I got the answer 10.14175. So it said 2 decimal places, I think 10.14. That's the estimate for the area. Next bit of the question here now, B is done. C now, use integration by parts to find the integral of x ln x. So part C now, x ln x. So integration by parts, I've got a decision to make, and the decision that I've got to make is which one is going to be u. So I'm going to use the late rule, log algebra. So u is ln x, which then differentiates to 1 over x. The algebra is going in here as v dash, and that will integrate to x squared over 2. So integration by parts, the rule is integral of u v dash dx equals uv minus the integral of u dash v dx. It is on the formula sheet in some form. So we have x ln x equaling uv x squared over 2 ln x minus the integral of u dash v. Now 1 over x times x squared over 2, and x will cancel with an x to give us x over 2 dx. So x squared over 2 ln x minus, raise it to a 2 and divide by it, minus x squared. 2 divided by 2 is 4 plus c. So integrated that. Part D of the question. Hence, find the exact area of R, given your answer in the form a quarter a log 2 plus b. A quarter a log 2 plus b. So we're being asked to integrate from 1 to 4 x ln x dx, and we know that that integrates to this, so we don't need the plus c, from 4 to 1. So we'll sub in 4 first. So 4 squared is 16, divided by 2 is 8 log 4, minus 4 squared is 16, divided by 4 is 4. Subbing in 1, 1 squared is 1. So half, log 1 is 0, so that's 0 there, minus 1 quarter. So 8 log 4 minus a 4. So this is 0 minus a quarter minus a quarter plus 1 quarter. Now the answer had a log 2 in it, so I'm going to call that 2 squared. So that's minus a quarter, minus 4 plus a quarter, that's minus 3 quarters there, times by the 2, 16 log 2. I'm going to write this as an improper fraction. 4 3s are 12, plus 3 makes 15, minus 15 over 4. Oh, sorry, I've got a page there. Let's have a look at the question. So then a quarter a log 2 plus b. So take a quarter out as a common factor. So a quarter comes out as a common factor. quarters into 16 would be 64. 64 times a quarter is 16. So 64 log 2 minus 15 there. So A is 64 and B is minus 15 in the form that they wanted it.